Okay, so last time we started talking about complex numbers or imaginary numbers, and as I mentioned in mathematics or any part of life, you have to have these axioms or these set of rules or truths that everybody agrees on. If not, then there's no point of having conversation. Okay, that one is equal to one, not one is equal to two. Okay. So in this case, I square is equal to negative one. That's the axiom. That's the truth that we all agree on. Okay. So based off this, then we can, you know, have these different expressions of what I1 through I8 is, or in this case, I1 through I4. So as you notice, we talked about last time that it has a pattern. Starts off with I, negative 1, negative I, then 1, I, negative 1, negative I, 1. So it goes through this pattern over and over. Okay. Now, also with complex numbers, another way to look at them is through a representation through a vector. Okay. So vector, remember, discusses or talks about having a length, magnitude, and direction. Okay. So 3 plus 2i can be represented by this vector here. We're not going to emphasize so much about vectors, but we're just going to do um, writing these complex numbers in standard form. And we started doing that on this slide where we will write each expression in standard form. Believe it or not, this problem here is missed a lot because students think it's being multiplied when there's actually you're adding or subtracting these expressions. Okay? So students try to multiply them, and that's not what you're trying to do. So they make it more complicated than it needs to be. Now there are times where you need to multiply them. But again, if there's a plus or minus in between these two expressions, then that means you're going to be adding, subtracting, and you know, um, that's how simple it is. And I also related it to this solving it to or simplifying just your typical linear expressions as well. Okay. So again, just be careful of that. If there's a plus there or minus there, you're adding, subtracting. If there isn't one, then that means you're going to be multiplying. And that's what we're going to be doing next here. Okay. All right. So again, we want to write this in standard form. Okay. A plus BI. Again, the A plus BI means you can have minus A, minus BI, minus A, plus BI. All right, different variations of that. It doesn't have to mean that all of them have to be positive. Okay, so let's look at this one. We have 5 plus 3i times 2 minus I. Okay, so we have 5 plus 3i times 2 minus I. There's a lot of ways to multiply these. Some people use the box method, FOIL method. All right, so many different ways of doing it. I just go, so I'll just show you the a couple ways that students normally do this. So first is the FOIL method, right? So a lot of students use the FOIL method to do that, and that's absolutely fine. All right, so the FOIL method is you take your first terms and you multiply those. Okay. Then you take your outer terms. So the 5 times negative I, you multiply those. Then you take your inside terms. Okay. 3i times 2. And then you take your last terms. So that would be 3i times negative I. All right. So you will get 10 here, negative 5i, 6i, and 3 squared. Right? And then we just combine them. So we get 10 minus 5i plus 6i. Now remember, I squared means negative 1, so that's going to be negative 3 times negative 1, okay? So that's going to give us a positive 3. Okay. All right. And then we just combine like terms. So we're going to combine the 10s here and then combine the i's. So that's going to give us 10 plus 3, which is 13. And then we have positive I. Okay. And then that will be our answer there. Okay. So that's the full method, which a lot of students use. The method I use is basically the form method, but I write it in a different way. And it's just using the distributive property. So, so what I do is I just take the 5 there, the first term, and then I multiply it by the second term. So let me rewrite this again. 5 plus 3i times 2 minus I. So again, I take that first term and then I multiply it to 2 and minus I. So 2 minus I. Then I take the second term and then I multiply it to 2 minus I as well. So plus 3i times 2 minus I. Okay. So then I get 10. Then I distribute this. I get 10 minus 5i plus 6i minus 3i squared. Okay. And again, I squared is -1, so that gives us a positive 3. And then these two will give us I, and then we have the 10. So we get 13 plus I. Okay. So different process, um, but to get the same result. Okay. And I know there's another one that students use using a box, right? And they write their terms that way. So you can do that as well. So anyway, it doesn't matter to me how you do it, whatever works with your brain. Okay. But I prefer to do it this way in the middle. Okay. All right. Any questions on there? Okay. So the next part here is what a lot of students mess up on as well. Okay. So let's say we have 13 divided by 5 minus 12i. Okay, and again, it's the same question. We need to write the expression in standard form. Okay, so how do we do this? Well, remember, if you have a radical in the denominator, right? We talked about this. So if I had like 2 over a radical 5, right? In order to get rid of the radical 5, I have to multiply the top and bottom by radical 5. Okay? And that gives us 2 radical 5 over radical 5 times radical 5 is radical 25, which is basically 2 radical 5 over 5. Okay? So it's called rationalizing the denominator. Okay? Rationalizing the denominator. You can also do it for the numerator. Well, we're going to do something similar, right? But in this case, it's called multiplying by the conjugate. Okay? Conjugate. What do I mean by conjugate? Well, it goes to the difference of squares. The difference of squares. Okay, so remember, if you have a squared minus b squared, we can break that down to a minus b times a plus b. Okay, so if I had x squared minus 9, right, I can rewrite that as x squared minus 3 squared, which is broken down to x minus 3, x plus 3, right? So those are just the factors of x squared minus 9. All right, so when they say multiply by the conjugate, so if we had x minus 3, the conjugate would be x plus 3. And vice versa. If we had x plus 3, the conjugate would be x minus 3. So it's just going to be the opposite. Okay? So in this case, that's what we're going to do here. The goal here, the goal is to eliminate, write that better, is to eliminate the I in the denominator. Okay? That's the goal. We want to eliminate the I in the denominator. So how do we do that? We multiply by the conjugate. And a lot of students will do that. Okay? But one thing they mess up on is that instead of doing by the opposite, they multiply by the same thing. Okay? So instead of multiplying by 5 plus 12i, they will multiply by 5 minus 12i. Okay? So you don't want to do that. Okay? You want to multiply by the opposite. So 5 plus 12i. Okay? And the only thing that's opposite is that I. So we're going to multiply top and bottom by 5 plus 12i. Okay? Then I'm going to do my scratch work. Right? So I'll do my scratch work. So the 13, all right, so I can distribute this. I'll have 13 times 5 plus 12i. And the denominator here, I'm going to put this on the side. So I got 5 minus 12i and then 5 plus 12i. Okay. So again, you can use the FOIL method, the distributive method, whatever method you like to multiply this. What I like to do is just using the difference of squares right here. Okay. It makes it a lot easier. So this is my, this is my a minus b. This is my a minus b, and then this is my a plus b. Okay. So what does that mean? That means I can just multiply them, right? A squared minus b squared. So that's going to be 5 squared minus 12i squared, right? I just plug it into that formula. So that gives me 25 minus 12 squared is 144. And then I squared, right, is -1. This would be I squared. And again, that equals to -1. So that's going to be 25 plus 144, which is 169, right? So the denominator here is going to be 169. Okay. All right. So, um, notice that a lot of times I don't really distribute the numerator unless it's going to help me. Okay. But notice that the 13 can go into 169, right? It can go into 13 times. So I can reduce this. So 13 can go to 13 one time, and 13 can go to 169 13 times. So I can reduce that. So this becomes 5 plus 12i over 13. Okay. Or we can write it as 5 over 13 plus 12 over 13i. It doesn't matter to me. Okay. So both are correct. All right. So again, the first thing we need to do is we need to multiply by the conjugate, correct? So hopefully we did that. So we're going to multiply um, the top and bottom by 1 plus I, right? So we're focusing on the denominator. Okay, we want to get rid of the I in the denominator. So we're going to multiply by 1 plus I. So the top and the bottom. Okay, has to be opposite. All right, and then I'm going to do my scratch work. So I'm going to do some scratch work here. Okay, so I have the 2 plus 3i times 1 plus I. And then we'll have 1 minus I, 1 plus I. Okay, so the key thing about solving complex stuff is to organize your work. So, right, to break it up into components and then put it together in the end. So this one here, I can't apply the difference of squares because they're not the same factor and not one being opposite. So I just have to use good old FOIL or just distributive method here. So 2 times 1 plus I plus 3i times 1 plus I. So we're going to get 2 plus 2i plus 3i plus, that's a 1 there, plus 3i squared. So that's going to give us 2 plus 5i. And remember, I squared is negative 1, so that's going to be 3 times negative 1, which is a minus 3. So 2 minus 3 will be negative 1 plus 5i. Okay? So that's what we should have gotten for the numerator. So hopefully that's what you got as well. Okay? So I got negative 1 plus 5i on the top. All right, so now let's work on the bottom here. Okay. So notice that this is the difference of squares, right? This is the a minus b times a plus b equals a squared minus b squared. So I can just use the formula. So my a here is going to be 1, so that'll be 1 square. And there's always a minus in the middle. So the b here is going to be I, so I squared. Okay? So we have to be careful. So 1 square is 1. We still got a 1 here. And then I square is negative 1. So that means we have another negative. So that's going to give us 1. Two negatives will give me a positive. So 1 plus 1 is 2. So the denominator here is 2. Okay? So you can leave your answer this way. That's totally fine. Or you can break it down if you want. Okay? Either way is correct. Okay? Okay, let's look at the first one. We have I to the 14th, right? So first, let's look at our pattern, right? So we know I, so let's just write it down here. I is equal to 1. I square is equal to negative 1. I to the third is equal to negative I. And then I to the fourth, oops, is equal to 1, right? Again, if you don't remember, you just draw the coordinate plane, right? Starts with I, or this is 1I, negative 1 here, and then negative I here. So you start from the top, I, negative 1. Oh, sorry, this should be I, negative 1, negative I, and 1, right? So that's the pattern there. All right, so here we have I to the 14th. Now, again, you can go through that pattern if you like. What I like to do is I like to use I square, right? Because that's what we're given. We know I square is equal to negative 1. Okay. So if I have I to the 14th, okay, I can rewrite this as I square raised to the 7th, right? Because a power raised to a power you multiply. So 2 times 7 is 14, right? So in this case, what do we know? I squared is negative 1. So negative 1 raised to the 7th power. That's just saying negative 1 times negative 1 times negative 1 times negative 1, 7 times, right? So that's just going to give us, since it's an odd power, that answer has to be negative, right? So negative 1. If it was an even power, then it would have been a positive 1. Okay? Okay? So that's how I would do that one. If you did it differently and got the same result, that's absolutely fine. Okay? Well, let's look at I to the 178. Okay, we have I to the 178. So again, I'm going to play off the square again. All right. So um, what can I multiply 2 by to give me 178? So again, I'm going to rewrite this as I square. Okay. Well, 178 divided by 2 is going to give me 89, right? Or 2 times 89 is going to give me 178. So I square again is what? Negative 1. So negative 1 raised to the 89th power. Again, it's an odd power. So that means then we're going to have a negative 1 again. Okay? So that's how I would do that one. I'm actually going to skip the third one here for right now and go back to that in a second. And let's go to the 4 plus I to the third. Okay, so we have 4 plus I to the third. Try that one more time. Okay, so 4 plus, well, I to the third, we already wrote that down, right? I to the third is negative I. Okay, so this is going to be 4 plus negative I, or 4 minus I. Okay, and that would be our answer there. Okay, and then this one here, we have 4I to the third minus 2I squared plus 1. Okay, so again, we have 4I to the third. We said that was again negative I. So I'm going to put negative I here. And then minus 2 and then I square is negative 1, then plus 1. Okay, so that's going to give us negative 4I plus 2 plus 1. So this is going to give us negative 4I plus 3. Okay, or 3 minus 4I. Okay, so if we have to write it in standard form, 3 minus 4I. Right, so remember, standard form is A plus BI. That's the standard form. Okay. All right. So let me pause here for a second. All right. So let's look at the last one here. So we have I to the negative 23rd. All right. So we have a rule here that says if you have A to the negative N, you can rewrite it as 1 over A to the N. Okay. Because as it stands right now, we can't do anything. We have to rewrite, we have to make that power positive. Okay. So in order to do that, we need to rewrite I to the negative 23rd as 1 over I to the 23rd. So let's rewrite that as 1 over I to the 23rd power. Okay. So now we can focus on the I to the 23rd. Okay. So I to the 23rd. So I'm going to follow what I've been doing. So I'm going to break it down where I can have I square, right? Because I square is very, that's what we know. That's what I always remember as I square is equal to negative 1. So I'm going to break this down to um, I square times, um, I'm sorry, let me go backtrack here. I'm going to break this down to I 22 times I to the first. Okay, because remember, you can add the powers. Okay, so to a 22nd times I to the first. So 22 plus 1 will give me I to the 23rd. Okay, so here I'm going to break this down to I square raised to the 11th power. Right, because 2 times 11 is 22. And then multiply this by I. Okay, you with me? All right. So then what does this become? Well, I square is negative 1. Negative 1 raised to the 11th power times I. Well, what is negative 1 raised to the 11th power? Well, that's just going to be another negative, right? Because it's an odd power. So negative 1 to the 11th power is just negative 1 times I. Okay? So negative 1 times I is going to give me negative I. Okay? Sounds like a pirate here. Okay? So in this case, I to the 23rd is going to give me negative I. So here, so again, this was our, break this, break this down here so that separate it from what we're trying to do here. So this was a scratch work. Okay. So this one now becomes 1 over negative I. Okay. So what do we notice? It's something that we've been doing, right? If we have that I in the denominator, we need to multiply by the conjugate. So in this case, we're going to multiply by positive I. Okay, so I over I. Right? This problem seems so innocent, but it's a lot of work. So we have I here, and then I times I is I squared, but don't forget there's a negative here. Okay? So we still got the negative times I squared. Okay? So that's going to give me I, and then the negative 1 times I squared is another negative 1. All right, so that gives us I over negative 1 times negative 1 is a positive 1. So our answer here is just going to be I. Okay, so let's read the definition again. It says if n is a positive real number, we define the principal square root of negative n, denoted by square root of negative n, as the square root of negative n equals the square root of n times I. Okay, it looks complicated, but it's actually not that bad. So for example, if I have the square root of negative 9, okay, 9 being a real number, I can just rewrite this as the square root of 9 times I, okay? So this becomes 3I, okay? So let me do it again. So let's say I have the square root of negative 64, okay? I can rewrite this as the square root of 64 times I, which becomes 8I, because the square root of 64 is 8 times I, which is 8I. Okay? So why don't you try one? So let's say we had the square root of negative 8I. And if you can simplify it, go ahead and use, oops, the square root of negative 8. There we go. Okay, so based off of this, right? This becomes radical 8 times I, and I can break down radical 8 as 4 times 2, right? And radical 4 times 2 becomes radical 4 times radical 2, which is 2 radical 2, and then I bring down the I, okay? And I can write that as 2I times radical 2, okay? Or any variation of that, okay? All right, questions on this part? Okay, so let's look at the last example. This one is using the quadratic formula. So remember, previously we tried to use the quadratic formula, and if we had a negative in the radical, we couldn't do it. But now, if we do have a negative, we can do it because we're looking in complex or imaginary numbers. Okay, so let me pause this for a second. Through this. All right, so we want to use the quadratic formula to solve this. As I mentioned before, before if we had a negative in the radical, we would stop, we would have no solution. But in this case, we would continue because we are working in complex world. Okay, so the first thing is we should label our A, B, and C, right? This is a 1, so this would be A, B, and C. Okay. So, and then we just plug in the information that we have. So we have minus 4 plus minus the square root of 4 squared minus 4 times 1 times 8. Okay, that's 8 there. Right, divided by 2 times 1. Okay, so let's look in the inside here. So we got negative 4 plus or minus. The inside here we get 16, right? So 4 squared is 16, and then 4 times 1 times 8, that's going to give us 32. So that's going to be negative 32, okay? All over 2. So again, normally we would get what? 16 minus 32 would be negative 16, and we would stop because we couldn't take the square root of a negative number. But again, we're working in complex world, so we can continue. So here in this case, we get negative 4 plus or minus the square root of negative 16, okay, divided by 2. Well, what is negative 16? Oh, square root of negative 16. Well, square root of negative 16, that's just going to give us what? 4i, right? That's just going to be 4i. So this is going to be, let me write over here, negative 4 plus or minus 4i divided by 2. Okay. Now, notice that every single term has a factor of 2. It only works when every term. So there's 3 terms. This one, and this one. So if they all factor by 2, then we can reduce it. If not all of them have a factor of 2, then we can't do it. So we can take out the 2 on the top. So that's going to be 2 times negative 2 plus 2i divided by uh, minus there, divided by 2, okay? And then the 2's are going to cancel, leaving us with negative 2 plus or minus 2i. And that's our answer there.